I think Pawan Kumar Jain sir has just joined us.
Okay.
Okay.
Jain sir, just for confirmation,
Am I audible?
Yes, sir, you
yeah,
are audible.
Okay, very good, great. Sorry for all this sometimes technical which comes.
Yes, sir. It's been
Yeah,
long time we met.
yeah, that's what I'm wondering because what is happening when we meet in person, then only things are different. But anyway, we will try to have, because those who have joined, if they can open their video so that it will be easy for me hmm, for a few seconds if they can open.
Yeah,
Oh, good.
participants, please switch on your cameras.
Yeah, no problem. If it is already, many people have joined in a. Hmm.
yeah, just now one session happened, sir.
Actually, previous session
Ah,
completed 10 minutes back. So,
10 minutes back. Okay.
yeah.
So will you start
Yeah, yeah,
immediately?
yeah.
Yeah.
Okay. I think. Right. Okay.
So,
So
yeah, I
one thing,
request.
small suggestion or something. If anybody is having, just raise their hand. We will stop and we can interact it. So there is no issue that at the end only because many times what happen, people forget what to ask. Hmm. So you want just an interrupt with the raising the hand. Let the admin will take a call whether to
Yes.
take up that question or not.
Yes.
Okay. Right. Good.
So, the participants hope remind that uh, freedom. And without any late, I request Caesar Rao sir to give brief introduction about Dr. P.K. Jain, who is going to give session right now. Thank you. Over to you, Rao sir.
Yeah, good evening, participants and respected speakers. I am Dr. C.J. Rao, Professor in Mechanical Engineering Department of ADITYA Institute of Technology and Management. Dr. Pawan Kumar Jain is a distinguished scientist and a leading expert in carbon materials research. He obtained his PhD from CSIR NPL, Delhi, specializing in carbon composites, following his master's and MPhil in physics from Agra University. Currently, he is serving as the Associate Director at the International Advanced Research Center for Powder Metallurgy and New Materials, Hyderabad, an autonomous R&D institution under the Department of Science and Technology, Government of India. Dr. Jain has been instrumental in pioneering advancements in nanostructured carbon materials and composite technologies. His research spans a wide array of cutting-edge areas, including exfoliated graphite and its applications, carbon nanotubes, graphene, conducting polymers, nanofluids, structural nanocomposites, and carbon fiber reinforced composites. Dr. Jain has successfully transferred key technologies to industries, including exfoliated graphite-based automobiles gasket sheets, fuel cell bipolar plates, and evaporation boards for metallurgy applications. Recognized for his remarkable contributions, Dr. Jain has received prestigious honors, including the B.D. Bangar Award from the Indian Carbon Society, ICS, in 2009, the Boys Caste Fellowship from DST India for research in Russia, and the Best Scientist Award by the Academic Brand Awards in 2017. He is a fellow of the Telangana Academy of Science and holds leadership roles as the National Joint Secretary of the Indian Carbon Society, ICS, and President of its Hyderabad chapter. As an esteemed academician, Dr. Jain is a member of various professional societies, a board member in multiple universities, and a recognized PhD guide for IITs, NITs, and other institutions. He has authored over 110 peer-reviewed journal publications, contributed 7 book chapters, guided 5 PhD scholars, mentored numerous MTech students, and holds 2 patents to his credit. Dr. P.K. Jain's relentless pursuit of scientific excellence continues to shape the future of advanced materials research, bridging the gap between academia and industry for the benefit of science and society. This is a brief introduction of the speaker, Dr. P.K. Jain. Sir, please.
Thank you very much. Thank you very much, sir, for a nice introduction. Am I audible?
Yes, yes, sir. You're audible.
Very good. So anyway, it's already briefed that I'm from ARCI. This is a center, and I'm going to talk about the synthesis of carbon nanomaterials and their various applications. Now, ARCI is a lab, research lab, which is a part of a Government of India, a Department of Science and Technology. We are not that big organization, about 80 scientists and 55 technical cadre and 45 administrative and supporting staff. And we have about 120 students, and all services, whatever we take, it is a security, area cleaning, electrical, everything is outsourced. So put together, we have about 450 to 500 head counts in our campus. We have a unique mandate to development of a high performance materials process for the niche market. Like we work on ceramic or polymers, but we work only for the niche market, and ultimately demonstrate the technology at the prototype or pilot scale. And this looks to be a very simple statement, but this is a very heavy loaded statement, because once in a research lab, whatever is done, it is into very low TRL level. So now industries is interested when this technology can be transferred to taken up to a large scale. That is only possible when you demonstrate that technology into a prototype or a pilot scale. And then eventually we transfer to technology to Indian industry, and technological solution to industrial and strategic sectors. We will show you some of the product where the strategic sectors we are the unique lab which makes the cater the requirement of particular component, whether it is space sectors or DRDO or atomic energy. And of course, as I told you, we have good number of students, 120. So this is a good human resource development, and we have all these things. This is our beautiful campus. When you go from Hyderabad, from airport to LB Nagar, you'll find this campus. So this is in a 96 acre and around 45 acres in the technical. And we have a lot of incubators. The whole ARCI is divided into many centers. The Center for Carbon Materials, Center for Soil Gel Coatings, or even the Center for Ceramic Processing, Center for Solar Material and Laser Processing, Engineering Coating, Nanomaterials, and Characterization. And we have two centers located in Chennai, Center for Fuel Cells and Center for Automotive Materials. And apart from that, we have a unique center called Center for Technology Transfer, which acts as a bridge between the industry and the technical center. The top four centers of ARCI, I am the associate director for all the four centers: the carbon materials, soil gel coating, ceramics, and the solar materials. And of course, we have one corporate office in Gurgaon that also I look after. So now coming back to, like, for example, ceramic, this ceramic centers works on the cellular and porous ceramic. I'll give you a brief of that. Already all those things are there in our website, and that we have a very good state-of-art facilities like hot isostatic pressing, and we do all sort of a powder synthesis, CVD, very high-end CVD is there. These are the few products which has come out from the oxide ceramic group, like ceramic balls, alumina balls, the spools, the catalytic converter, the honeycomb, and from that honeycomb, eventually we have developed the anti-mine boot for our defense personals. Because whenever any person keeps their foot onto the mines blast. But if it is because of the structure of this honeycomb, the most of the impact is taken care by this honeycomb, and the very, very low impact will come on to the human. So this is already we have transferred this technology through DRDO to now Bata is making a big numbers for the army. Now this is a non-oxide ceramic where we are working on silicon carbide, and you can see here, these are the few silicon carbide components are there. The mirror, the ADITYA mission also. This satellite mirror is also fitted with this center. We have a laser processing which can do all sort of a laser cladding, laser welding, laser joining, dissimilar laser brazing. All sort of lasers are possible in our laser center. These are the few components which has been made. Looks to be simple, but if you want to drill a hole of a few micron into a big slab, it is not possible with the normal technique other than the laser. And laser has its own advantage that local you can avoid all sort of a microstructure changes, and very localized heat is generated, and the overall component can be developed. You can see very high performance jet beams for the aerospace, and this is micro machining. Ultra fast micro machining laser is also there. Diode lasers are there. This is Center for Engineering Coating, which is having state of art technology. This coating facilities like thermal coatings like D-gun or plasma coatings or HVO, high velocity oxygen fuels. So this center do a lot of job work for turbine blades and other these things. So this is a big center which is doing a lot of technological development. And this is soil gel coatings. You must be knowing also the soil is prepared and then the soil gel coating. So this is a state-of-art lab where in a big quantity we can produce these materials, and then it can be given a coating, and to like our helicopter films, helicopter windows, where the anti-scratch coatings and other things are being developed by this center. Now this is a solar material, so we have a lot of solar panels and other things which is given like a PV photovoltaic solar cell, thermal solar cell, perovskite solar cell, dye-sensitized solar cell. So we have a pilot scale facilities, and we do a lot of anti-reflective coatings, dust repellent coating, and all sort of coating onto the solar cell. These are the few set of lines you can see. CIGS is state of art. I think in India we are the only one who is having such type of facilities and high-end solar. And this center has transferred technology to Borosil for making a anti-reflective or a self-cleaning coatings, and a very big amount of royalty also ARCI is getting. This is Center for Nanomaterials, like different type of in a quantity, very good quantity in kilogram level. We synthesize the nanomaterials, all sort of nanomaterials. We have a very high-end Jaws mills, atomizers. We do a lot of product development, and this center has transferred technology for antibacterial coatings onto the textile. And commercially, it is available in the market in the name of flying machine, and other genes are there where such type of coating is given, which is you don't require it is an antibacterial coating onto this textile. And this technology also is being transferred. Apart from that, this center has also developed a LFP, a material for battery. And this particular technology is incubated in ARCI. And just to give you a flavor of that, the company has transferred technology in 3 crores, but the company rating, when they have come out with the public issue, it was rated like 800 crore, because general impression, if it is a technology from ARCI, it must be a high valued. This is a hydrogen a center for fuel cell, which involved into hydrogen generation. This center is located in Chennai. So hydrogen generation and then fuel cell also this thing, and SOFC, SOEC, all sort of most of the components are indigenous except like a membrane, but we are doing this Nephron membrane which we import, but otherwise like bipolar plates, other things are all in-house developed in ARCI. The graphite bipolar plate is being used. We'll show you how it works. And these are the state-of-art facilities in Chennai. This is located in IIT Tech Park, Technology Park of IIT Chennai. And this is a center for automotive materials which involve into, we have a very big battery line, continuous battery line is there. Apart from that, they work on magnetic materials and so on. And this is a center for carbon materials where the aligned carbon nanotube, exfoliated graphite, different type of products are made from this. This is a few products and a few facilities of this. And this is you just name any characterization. ASA is having that type of characterization, whether it is structural or microstructure or mechanical or electrochemical. We have a very good professional scientists, those who are experts to give a solution for all type of characterization. And you can appreciate without the characterization center and the good characterization facilities, because nowadays research is zero down to the characterization. If you have a very high end impact characterization, then only it can be published into a high impact journal. Otherwise, the low end characterization will not result into a high impact journals publications. Now, we as those who have visited, we have all micro XRD, the dual beam and nanomechanical testing. And apart from that, some of the things are already latest included, like a high temperature mechanical testing. The SAX is there, the high-end TEM is there, residual stress. You just name anything we are having in our center. Apart from that, centralized facilities, all the centers are having some of the characterization, like in our carbon center, we have a laser flash for thermal conductivity, simultaneous thermal analyzer, a very high-end inkjet printer, which is, you can just imagine the cost of inkjet printer is around 3 to 4 crores. These are the few technologies which we have transferred to various industries. And these are looks to be 20, but till now we have transferred more than 28 because some of the technologies have been ready to multiple industry. The last two technologies I was the project lead. Now coming to this is a very, very important, because why this slide I kept here, because this will decide the difference between the normal university research or to the applied research or to the industrial research. What is happening when you are doing into a basic fundamental research, you are working onto a TRL, very low TRL level. That is technology readiness level. And like, for example, if a person is doing a research in their lab and found out any good compound, and it is a eureka moment for that scientist or a researcher, but the industry will not take forward that type of research because they requires a concept of whether it can be doable into a larger scale. So a lot of things get involved into this. It is not simply just finding a new product, that it has to undergo a lot of validation in the lab, validation into the field trial, the all environmental conditions. It is into the actual simulated conditions we do testing. And then suppose we are developing a high temperature material, for say 1000 degree, it has to be used. So we try to simulate that type of conditions like a field trials, and then only we declare that as a product is successful. It is a continuous interaction with the user and the developer. So we are more strong into taking things into from TRL, low TRL to high TRL. And most of our technology, when we transfer, it is at the TRL 6 and 7. Then only it goes into the market. And to start this thing, whenever we transfer for initial period, we handhold the industry so that there will not be any issues or any complexity. We try to help them technically and everything in the correct direction. Now coming to this slide, this is what happened in last few century. We have seen the research, overall internationally research is driven by new development. Like if you see in the first half of the century was the vacuum tube technology, where we have seen the invention of television, radar, radio. Then it has come the semiconductor technology, where we have seen the internet, cell phones, computers, transistors, radios, whatnot. And nanotechnology, this is the era of nanotechnology, biotechnology, everything is in this era. After 2000, we are now, just to give you a flavor of the role of materials, semiconductor technology here. This has come when after World War, there was the Japan was a completely destroyed country, and but just because of the development of a silicon, finding silicon for electronic industry, a lot of industries, electronic industries, have come in the Japan, and Japan has become almost like a third economic power of the world. It does not have any other thing other than the technologies. They don't have any natural resources, any natural minerals, or even you will be surprised to know the vegetables and the fruits also they import. But they are the third largest economy of the world just because of the materials, how to take this material into the industrial application. Now here we are. Now if you see, just to give you a flavor, all these, whether it is radio, the video cameras, the VCRs, televisions, pictures taking cameras, computers, all music listening, telephone, fax machine, alarm clock, whatnot. Now you will not see all those items into your day-to-day life. Just 20 years back, these were very common gadgets in everyone house. But now everything is confined to this cell phone. Even the money transfer also can happen through the cell phone. So that's how the technology takes into a lead. Now, coming to the nanotechnology, whether really the nanotechnology is new or we are looking from a new perspective, that is very important to observe here. If you see the historical use of nanotechnology, in the Europe, you will find a lot of, like in a museum, Lagergas cup is there, which is considered to be 4th century AD, made from a glass impregnated with the gold nanoparticles. And when you pass the transmitted light and under the reflected light, you can see the difference in color. So nanoparticles was there. There are a lot of nanoparticles are dispersed in glass, which is used as a painting or as a window, and it lasts for few centuries. Forget about this. Even the artifact which was found in Harappa and Mohenjo-daro, there also people have found that a lot of nanoparticles are there. Now, even you will surprised to know the Katuka or the Kajal is also having nanocarbon. And we don't know since how long we are using this particular Katuka or Kajal, maybe to few thousands here. But now we have the equipment. We have that equipment which can decide what is this black color powder which we are applying into the eyes. Now we know this powder is nanocarbon, which can absorb the ultraviolet rays, and then that's why it protects the eyes. Now our ancestors in India, they were very clever guys. They may not be knowing that the technical word, what is the present technical word, but they were knowing that some powder, if you produce through any oil and make into a deposit, it is nothing but like a CVD. Chemical of oil is vaporized and deposited, CVD, chemical vapor deposition. Deposition can be done onto any container or anything. There are little technologies involved because if it is a cool surface, the condensation happens very fast and the Kajal or Katuka is made very good quality. But now doctors suggest not to use it. Reason is because we Indians are little lethargic. So once we make it, we want to preserve it because utilization is very, very small quantity. We want to reuse it for many days, many weeks, and that's why contamination happens and doctors suggest not to use it. If you can afford making every day, this is one of the best things to protect the eyes. Now, all this thing, nanotechnology, we have seen, because in any given search engine, it produces many hits, more than 1.6 million hits will be there. And apart from that, nanotechnology influences almost every facet of our day-to-day life, whether it is electronic industries or space industries or even the biotechnology, the defense sectors, the sports sectors, and the cosmetics. This is only few photographs I have put, but if you go to the cosmetics, biomedical, everywhere nanotechnology is there. And this is the platform where one can, earlier it used to be the biology researcher will not interact with the mechanical or the chemical. There used to be clear-cut distinction between the mechanical, chemical, or in the material scientist or into the biotechnology. But now this nano has brought them, everybody into one platform. You will find applications of almost all field. And apart from that, a big money is there because all government wants to get involved into the nanotechnology because this offers a very good possibilities to develop a new materials. Now, if you see, whenever we want to do research, we are observing that we go to the Google and try to search what is happening into the rest of the world and try to see what are the gaps between those research what people have taken up and try to take those topic as our research topic. But you will surprise to know in Google also somebody is loading. So who takes the motivation? Those who are the real leader in science, those who are doing the cutting edge science research where nobody has done. So nature gives you the idea. The nature gives you idea how to carry out because nature itself is a very the God. What we say is the ultimate researcher or scientist. If you say whether it is the design of a bird's eagle, when it is coming down, it closes its wings, and similar design is in aircraft is taken, and similar like how you go into a high altitude, similar type of design is taken into such type of aircraft design. Now, spider net looks to be very simple, but you will be surprised to know spider net specific strength is very, very high. Specific strength in the sense the strength divided by the density is very high. In fact, this is the motivation to develop a very nanofiber, and whether it is a polymer fiber, carbon fiber, basalt fiber, all those things, the first motivation was the spider net. Now one can see in the lotus leaf effect, now we are developing a hydrophobic coatings. So all these things, the effect has come. Why people, the droplets is not able to adhere? Why it is repellent? Why it is hydrophobic? The science also we understand, and similar type of concept we want to introduce into in our hydrophobic coatings. Now, one example, if you see the mosquito, the thorns, whatever it is used, it is acting as a sensor, and it senses where the blood is there, and the same thorns will be used as drilling into that particular location of a skin, and once it is drilled, then it used as a sucking machine. It sucks, and it sucks almost like 5 times of its weight, and then it becomes, after drinking that blood, and then it flies off, which is like a flying machine. It's such a small nano machine which acts like a 5 different type of activities. Can you imagine? That's the nature, and this is the motivation for all researchers to do such type of research, the miniaturization where such things can happen. Now, another few examples of these things. Now, research is happening when in a Second World War, people have seen the very big cameras. One has to, like in a watchtower, carry that camera and take the photograph, and then after a few days, the photograph print will come out. Now we have a drone which can fly off any point, any part of the point wherever you have a good control. It is very ultra high distance. If you see the 500 years before or few hundred years before, this all fighters, they were using that type of gowns which was made from the iron and which was weighing almost like a 35 to 40 kgs. Now you just imagine when you are going for a fight, 40 to 40, around 40 kg weighing, you are carrying in your shoulder, your efficiency will come down. Now you are having a 2.5 kg bulletproof jacket, which is ultra efficient, which can stop the bullet. Now this man has predicted the computer will be like this in 2004, but now we have a computer laptop like this. So every time, now sometimes this fantasy movies also gives you a new idea. Now you see the Superman. 50 years back when we used to see the movie Superman, we used to feel it is a fantasy. A person is wearing a special type of dress which will not, your bullet will not affect. But now it is a reality. We are having a Kevlar-based, graphene and Kevlar-based dresses where the bullet does not affect. Now spider net. Now this we are having a special type of chemistry into that, where by which you can have a adherence with the wall, and you can climb it. The Batman, or even flying, or even the Hollow Man. For example, Hollow Man means what? You are not visible to the other person. Now, look, this is a concept. Nowadays, fights are happening between in weapons to weapons. If your missile is becoming invisible to the other enemy's radar, then it means you have become a Hollow Man, because you are not visible. And like in our mythological books also, Mahabharata, Ramayana, lot of things are there where we have seen the Pushpak Viman, even the Hanuman can fly 90 kilometers or 90 miles. So that type of things was there. These are the motivation, how people do, how to make yourself motivate, what type of directions. Now, some in nano, in our day-to-day life, because if those who were senior people, they must be knowing 30 years back, there was a field called superconductivity, and which has given a very high hope to the society that it will change. There will be no loss of when the current will conduct. But now, unfortunately, that has not fulfilled the need of the society. Now, similarly, in nano, people who are having inhibitions where the nano will also be like will not fulfill the demand of the society. But fortunately, nano is fulfilling, like whether it is sporting goods or paint and coating, computer chips, nano composite. You just name anything, it will be nano will be there. You just see a few examples of nano coatings, like in your gas stoves. A coating is given where the spatula or the knife will fall, there will not be any scratches. The scratch-free coatings are there. In your refrigerator, in your washing machine, nano silver is given a coating, and this looks to be oven, but this is like a shoe locker, where if you give a nano particle, silver nanoparticle, all the bad smell will be absorbed by that. Because in many countries, this bad smell is not that good, because they have a less water. India is also having a tropical country, and here also we have to preserve the water. Now, like in cosmetics and dressing, a lot of chemical, the creams have come up based on the zinc oxide and other things, nano zinc oxide. This heating or the air filters and the water filter, which was not very, people are not very too much, the takers were very less before Corona. But after Corona, in many houses, it has become like a very, very popular. In fact, the sales of this type of filters have gone exponentially very high after the Corona, because the air what we breathe, especially in the metro cities like in Delhi, the quality of air is very, very poor. So you require a specific type of, and everywhere, whether it is an air filter or water filter, nanoparticles are there to support that. Now, this looks to be a little different, like in your surgical tools. If it is having a rust or something, it cannot be used. Your kitchen tools are there, which you require, which will last for many years without losing the shine and other things. Your coatings onto your jewelries or even the watches, sputtering coating is given. In your cameras, a high-end coating is given. Now, very typical example of a tiles. If tile is given a coating, it becomes like a hydrophobic, no water droplet will stay. The similar type of coating is given onto the top of the roof of this thing. But if you just imagine a building, very tall building, say for example, Burj Khalifa. Now, Burj Khalifa, if you want to paint it, there is no conventional technique by which you can do the painting. We cannot do like a hanging person of 150 stories. So you are forced to develop such type of panels which are self-cleaning, having the ability to self-clean. Whatever dust or water is there, it should be able to repellent that. And that's the technology which is finding in the day-to-day applications. Now, ultraviolet UV protection, as I told you, this is very, very because of the greenhouse effect, our ozone layer is depleting. So UV protection is very, very important for nowadays in this. Now, this another industry is packaging, food packaging industry, which is growing at the speed of more than 20%. Because Now everything comes in packaging. Your food items, I'm from Hyderabad, and Hyderabad is famous for biryani. But if I want to come to any other place like Delhi or Bombay or Calcutta, the packaging becomes very important. Just these are the food items where but packaging is very, very important. I'm basically from Agra, as it was told in my introduction. My hometown is Agra, and Agra is very popular for the shoe market. So one of my friend got the order of 1,000 shoes to Switzerland, and he has supplied it. But very surprisingly, very shortly, those all thousands shoes pairs have come back because there was a fungus on the leather. So you require a special type of a packing for the cold countries, which he was not aware. Now that's how it comes in different places. These chemical warfare or protection against the chemical and the bacterial warfare. This was not very common 3 years back or 4 years back before Corona, because this type of dresses were designed in such a way only the soldiers will wear at the time of chemical war or something. So one of our lab in Gwalior, they are working very vigorously on this type of chemical and bacterial warfare. Now in this canister, in the mask, whatever you use for the breathing, the carbon is kept inside to give the extra. Now this is in the medical line. This is called targeted drug delivery system. Now, unfortunately, some people suffer from cancer or something. So when they undergo with the chemotherapy or the radiation or even the direct injections, medicines, so what happens, these type of drugs, they affect not only to the cancerous cells, but also to the good cells. And because of that, the body swells, you will have a hair fall, you become a little not good looks body. So now this is very common. This is becoming very popular in the Western world, where the drugs are targeted to the cancerous cell only, and effectively you can utilize that. Now this is for that cream. Now if you see, a few years back in cricket grounds, a lot of players used to apply. They used to apply the cream, and cream is visible. But now this cricketers are not using such type of creams. So we cannot predict like the sun has become weak or cricketers nowadays, the players are very strong. But the cream what they apply is nano in nature. The nanoparticles are there. Those are invisible. Whereas if earlier it used to be microns particle which were visible. Now if you see into the skin also, when it is a nano dispersed particle, it penetrates very fast because natural force of a skin is still macro, and they allow accommodate the nanoparticle and it will heal very fast. Now, as I told you, the textile is given a hydrophobic coating or antibacterial, where you can directly, even the beverages, any coffee, rum, whiskey or tea, falls, you need not to wash, it will just wipe out. Now, if you see, when you go to a Western country or the cold countries, generally people don't wash the clothes regularly, frequently, because there is no sweating and no dust get adhered to the cloth in those countries. Whereas in India, the dust or sweating, they adhere to the cloth and it gives a bad smell, and you are forced or compelled to wash the clothes very fast, very frequently. Now this requires, you will be surprised to know, around 60% of potable water or drinking water goes into the washing purpose. And India is having a dearth of water just near to our Hyderabad, Maharashtra, where the water scarcity is so high that sometimes a train is given to a particular place to cater the need of water. Now, whether it is in glass specs or into the everywhere, you will find the nano. Now, like in a tennis racket. Now, tennis racket, because of the nanoparticles or the fibers, the reinforced composites are there, you will get extra flexibility. Just 35 years, 40 years back, the Wimbledon champion 7 times, Bjorn Borg, was a Wimbledon champion, but his service was around 120 miles per hour. Whereas now Nadal is doing a service of 150 plus. And so can we interpret from that this Nadal is more stronger? No. The Nadal is same, Bjornborg is same, but only the extra mileage they get it now. New players are getting from the high flexibility of the rackets, and which gives the additional advantage in the service. Now you just see disperse these particles into any solution, you will get a different colors, and the particle diameter will decide the colors, and we know now these are all our wavelength. Now this nano, we have seen this nano is very important, but why it makes important? Because the surface area of nanoparticles are very, very high. If you take a cube of 1 centimeter, and then the surface area of a 1 cube is about 6 centimeters square, because it is having 6 faces. But now cut this cube into 8 pieces, and each pieces into 8 times, and repeat it 24 times. From the same cube, you will get a powder which can cover the football stadium. Now, this high ratio of surface to volume is very, very important in day-to-day life also. Now, just to give you a flavor of that, if a particle is of having a 10 micron diameter, the surface area is around 0.22 meters square per gram. Whereas, in the same time, if you are having a 50 nanometer diameter, it will be 44 meters square, almost 200 times more, just by change. Now, surface to volume ratio. This is also very important. If you want to, suppose your mother gives you a hot milk and you are in hurry, you want to make it cool faster. What you do, you pour from one container to other container, or else you pour the milk into a bigger container which is having a wide diameter, or else you just start with the mouth, you start making it cool. In all the cases, whatever you are doing it, you are bringing more particles onto the surface. Whether you are pouring from one tumbler to the other tumbler, or you are putting into the bigger container, or you are putting into water rotation container, everywhere you are bringing more particles onto the surface, and that's the advantage. So in nanotechnology, already the particles are onto the surface because their particle size is very, very low. So you will get more functionality, or you can do a lot of activities with the particle with a small quantity. Now this is in nanotechnology, or nanoparticles can be achieved by only 2 techniques. One is top-down approach, another is the bottom-up. You take the bigger particle and go on crushing it, you will get the particles of a small size. Or bottom-up, you take the chemicals and then try to atom by atom, you deposit it, and you will get a bottom-up approach. In both the cases, you have advantage and disadvantage. Like in a top-down, it is very less expensive. In any lab, you just purchase any ball mill or something, you will get the nanoparticles, and it is well-established technology. But disadvantage is it will give you a irregular nanoparticles. There is a possibility of introduction of defects and impurities from the balls and the container or the milling additives, whatever you are using it. Now, but bottom-up looks to be simple, but a lot of chemicals, whatever you are using, lots of solvent, they are expensive. Sometimes the disposal becomes an issue. So every technique is having its advantage and disadvantage. You have to select depending on your applications. Now, this slide is very, very important. Why nanotechnology is important? Because when you are working in this nanotechnology, if you take the particles in nano size, the electrical properties changes, your magnetic properties changes, mechanical properties changes, your optical properties changes, your chemical properties changes. So what is left over in the material except the name? Suppose iron, the electrical conductivity will change, the melting point will change, the magnetic properties you can manipulate, mechanical properties, everything you can change except the name iron. Now that there comes that impact of nanotechnology. Now we have come to a juncture where we can redefine the predictable. And that's why a lot of government agencies, various countries are giving a lot of funding, because now we have an opportunity to recreate the world as per our requirement, or the materials as per our requirement. Now we'll talk about something about carbon. Carbon is a well-established material. Since centuries, we are using carbon. But every time, carbon offers new and new materials. Till before 1990, people were thinking carbon is such a established material which was used for energy like in a coal or diamond or the carbon fiber, the carbon black, or even the a lot of activities, coal tar pitch, mesophase pitch, everything was there. All of a sudden, the fullerenes came into the picture. When in 1985, the first report came by Smalley and group, the scientific fraternity has not believed that carbon also can exist in a circular form into a fullerene structure. It took almost like 5 years. It is nothing, not a century old. 5 years for scientific community to accept this, that carbon is also stable form in the ball form, and that is called the Buckminster Fuller in the fullerenes form, where the C60, C70s are there. And just after fullerenes acceptance in the scientific community, the carbon nanotubes came into the picture. Now, if you see the carbon, which is having the sp2, sp3 hybridization, we will get the one of the hardest material in nature is diamond. Of course, people use for ornament and other things, but it is having a very high impact industrial application. The graphite with the sp2 hybridization, of course, there are a lot of carbine and other things are there, which is there, but very limited numbers. So we'll not talk about the diamond because that itself is a big area to talk. We'll concentrate only on the graphite. Now, graphite, the physical properties are very, very simple. It is having a very low density material. And what is the main important characteristics of this graphite is it is a low density, it is chemically inert. You take the graphite block, put it into any chemical, including the hydrofluoric acid also, nothing will happen. A high thermal and electrical conductivity, low coefficient thermal expansion. These are the very, very important properties which make this material for aerospace application, because when the expansion is high, you cannot use it because all your design will fail. And the low coefficient of friction, self-lubricating, and the biocompatible. Biocompatible in the sense it does not react with the blood cells when it is inserted inside, whether it is this carbon plates for bone or anything. But what makes it a important thing is it is the only material in the whole periodic table which can retain strength at high temperature. When you take any metals, anything, the room temperature strength is very high, but once you start heating it, the strength, everything comes too low. But the carbon, whatever strength you are measuring at room temperature, it can retain up to 2500 degrees centigrade. These are the few areas where it finds applications like in a brake disc, rocket nozzles, nose tips. Now this looks very names like a brake disc. I will show you the photograph of brake disc. In all your aircraft, the brake disc is made from the carbon. Now this brake disc looks to be very simple, but imagine a 500 tons aircraft running on a runway with a speed of 800 km per hour, and it has to give a braking system within half a kilometer runway. Now this energy, half mv square, the kinetic energy will go into the only braking system. Now because of that energy, that heat generates, unless this is a very ultra high conductors or these things, it will not, all materials will melt. Now rocket nozzles, nose tips, all missiles, whenever they are re-entering into the space, the temperature come across.
May I interrupt you? Like there is a raised hand here.
Oh, I cannot see that. Okay.
Yes, yes.
Yeah, please. Tell me.
Yes, Pavan Rejeti, please ask. Pavan Rejeti, please ask. Otherwise, you can chat, post your message in the chat box also.
If you have, otherwise we'll go with the presentation. We'll continue. Is that okay? If you have questions, please ask. I think it has gone back.
Pavan Rejeti, please ask.
Unmute yourself and ask. I think you.
He is unmuted already. Yeah, he has questioned. Maybe his mic has a problem. How do nano coatings improve the environmental resistance of plastics, such as UV protection and water repellency?
Yeah. You have to play with the chemistry of that these things, because if you know the substrate chemistry, that whatever nanoparticles you are using it, depending on the application, you have to do that type of coating. It will not be one universal coating will work for all the things. So depending on the application, we have to select the coating and the technique. See, sometimes the hand layup technique can work. Sometimes spray techniques are there, and in plastics, suppose plastics are used only for the low temperature applications. So coating will be functional coating, may not be structural coating. Okay, for particular function, it will work on that. If
Any
you
other
are
questions? Sir, may
Okay.
you lower your hand, please?
Yeah. So now, because I cannot see who has raised that, because it is a full screen. So now, this, if you see the nuclear war reactor, the first wall of all nuclear radiations, nuclear.
Sir, there is one more question. Sorry to interrupt you.
Yeah, no problem.
Yeah, in the chat box, someone has posted, Turala Narayana Rao, what are the challenges in dispersing carbon-based nanoparticles in polymer and metal matrices for aerospace applications?
Yeah. I think in the later slides, this type of question, this we have answered. At that time, we will take up this question.
Okay, sir. Okay. Yeah,
This
please go ahead.
This is a very good question, and with this we did some work on this person. We will discuss there itself. So this wall of nuclear reactor, most of the wall, this always, not most, always it will be graphite. Dye and molds. Like if you want to press any material at 2000 degrees centigrade, there is no dye material which can withstand 2000 degrees except the dye graphite. So all those chemical applications, hydrogen storage, batteries, fuel cell application, carbon is inevitable. Okay, pencil, heat insulators. Few examples I will show you. Like these are the dye which we have used in our pressing the component. These are the electrode which is used in all our metallizing industries, or even the metallurgical applications where the temperature goes 1300, 1400, 2000. Now all graphitic furnaces, 2800, the electrode is always a graphite. Paint industries uses carbon. So all these things are there, like carbon fiber-based bicycle, which is very expensive but very, very light. In India, cost is a very major factor, that's why people don't use carbon fiber-based cycles. But all tires are black because carbon black is used. Hockey stick, golf sticks, baseball, everything is in the carbon fiber. Now, this is a few other industrial applications which we don't come across see day to day. But if you see, every time your AquaGuard person comes, he only changes the activated carbon. Now, industrial activated carbon-based filters are there, for which is for effluent treatment. The corner one, the graphite bush, looks to be very simple, but very, very high volume component, because it runs in millions of dollars. The industry operate. The cost is very low. These are the graphite foams are there, which we also have developed, which is used for the filtration, radioactive materials or the chemicals. Now, day to day, this thing also, the artificial legs based on the polymer composites into the limbs, this type of rings are made for the fracture surfaces for the animals, and the face packs, the toothpaste, toothbrush, everything is made from the carbon. Now we'll talk about the carbon nanotubes. Now that question, whatever will come in the coming slide, it will come. The carbon nanotubes are the seamless tube, which is nano size and made out of carbon. And if it is a single wall, it is if it is having a one wall, it is called single wall carbon nanotube, or otherwise it will be called multi-wall carbon nanotubes. Now, all these shapes and other things, how it takes, it is a different type of these things. You can control. Now you just compare the properties of these carbon nanotubes with the one of other high-end materials. Like the strength is 45 billion Pascal against the steel alloy, which is having a 2 billion Pascals. That conductivity estimated is 10 to the power 9 amps per centimeter square, whereas copper wire is hardly 10 to the power 6. The cost is, of course, very, very high. Is there. And the application, like people are talking about the high lithium ion batteries. The lithium ion goes into where? It goes into the graphitic structure as an intercurrent. And that's how you are getting the charging and discharging. So the research is going into batteries or electrochemical. And these are the few areas where this also offers as a hydrogen storage material. Of course, the reports were not very consistent because of the technique or because of the material developed. That's why this is not very popular material now for hydrogen storage, but once upon a time, very, very important. Few applications like as a cantilever or carbon nanotube will act as a base to absorb the proteins. Now, this is another interesting application into the probe for AFM or STM or this thing. Now, people will be, you will know, and the SCM is now called field emission, FESCM. This FE field emission has come because of the probe, and the nanostructured probes are there which work on to the field emission effect. I will show you how it works. This is a nano tongue because in the beverages industries, like in a red label tea or yellow label or green label, how it will be distinguished. So now there is a nano electronic tongue. Earlier used to be a one person who used to test it and then decide this particular beverage will come. In electronic industries also, this carbon nanotube finds a lot of application in actuators or something. Now, as I was talking about this nanotube as a sheath material, this, if it is a missiles are coated with this. Now, if you see, all the fighter planes are black in color, but all civilian planes are white or silver or something. Why black? Because the carbon-based coating is given so that they can. It is called the stealth applications. These are the few setups what we have in center. The arc discharge, where the two graphite electrode is kept and passing a very high current and at a specific voltage, and you will get a deposit of this particular deposit, and this deposit will have a lot of carbon nanotube. We have the chemical vapor deposition. This is another setup, arc underwater, laser ablation setup, and the fluidized bed reactor. Commercially, the fluidized bed reactor is very popular because you can produce carbon nanotube in tons. But however, CVD is also used for the making different type of functional requirement, whether it is a pillar or the flakes or everything. You can design your catalyst and other things, which is possible. Now, this is now onward that dispersion issues will be taken up. Now, carbon nanotube, when it is reduced, synthesized through an arc discharge, it is having a lot of other graphitic or carbonaceous material which has to be purified. Now, this purification requires steps of thermal treatment, mechanical milling, and the chemical treatment, or the combination of all. And then only you will get the high purified carbon nanotubes. Now, this carbon nanotube, if it is not dispersed, it will settle down like this in a bottle. So it has to be dispersed. Then only you can find the applications. Or in a polymer matrix, how to sonicate it, how to make it into that. That is a tricks of that. You have to sonicate into a particular solvent and then disperse into a polymer. Otherwise, if you don't do sonication, we did study like 5 minutes, 10 minutes, 15 minutes, and 30 minutes. And we found that a lot of agglomerate particles are there in the low timings, but you increase the timing, those particles will be well dispersed. We have, is that question answer? Is that okay? Or you still have some questions? Because you require a proper surfactant, a very small quantity of surfactant, proper functionalization of the nanoparticles, what type of, where you want to disperse it, and then disperse it. Because the challenge on dispersion is the charge onto the particle. And this charge is measured through zeta potential. Okay. Now, how to control those charge is a skill. Now, when you cannot control, you have to disperse it in such a way and put in between a surfactant layer so that each particle will not agglomerate, and once they will not agglomerate, they will not settle that easily. Now we have also developed some sensor, EMI shielding, and putting into the different type of materials. Now we'll talk about the carbon fiber. The carbon fibers are very important class of material. If you just compare the metals, glass, aramide or carbon, you see metals are having a very good strength, but because of the high density of metals, the specific strength is low. The specific strength and modulus in the sense which does not a sort of a, you can say, rigidity. Okay, which will not undergo any strain in the high load. With a low strain only, then it is called high modulus material. So the carbon is enjoying the very good high specific modulus as well as the specific strength. Now, if you see carbon fiber, this is made from the few sources like polyacrylonitrile, pitch, vapor grown or rayon based. If you compare the human hair, this is the nanofiber. How it looks also, the microstructure is like this. Now, carbon fiber is made by this technique where you take the pen based fiber, polymer fiber, and stretch it like this is called stretching process or stabilization process, then carbonize it and graphize it, and finally give a surface treatment, and then you will get the commercial carbon fiber. And another way is to use the coal tar pitch, which is a byproduct of a petroleum industry, and you draw through a spinning process, and that fiber you carbonize it, graphize it, and that gives a very, very high-end carbon fiber, which is used in mainly in the aerospace industries. These are the carbon fibers. And now, whether you want to use it into 2-dimensional or 3-dimensional or radial, all those things are there. Now, carbon fibers are also fine depending on the applications. You can select whether it is for the cycle or for the aerospace. So, high modulus fibers are used always in aerospace industries. This is the technique how one can make the composite. Now, these are the carbon-carbon composite. You can see the leading edges. The temperature goes very, very high. These are the missile nose tip, which is, this is a full missile, and here the nose tip, which is made out of carbon. This is the aircraft brake pad, where, as I told you, it goes as a stator and rotor assembly, and around now in most of the aircraft, the 50% to 60% is made out of carbon fiber-based composite. Now, dispersion in the polymer, another question was how it has to be dispersed. It is a polymer which is having nothing. 1% weight CNTs is dispersed into an epoxy sheet and it becomes completely black. And this is the dispersion of CNTs. A very, very good dispersion. And that's the reason we can enhance the properties almost double. Now, there is a difference between dispersion and distribution. Dispersion is all the particles has to be entangled with each other. Then only you will get the best properties. As I told you, the field emission, this is a field emission of carbon nanotube. The field has to be very, very high in the order of 2 to 3 volt per nanometer. And because of that, if a material itself is not having a very good properties, it will have a lot of chemical activities are there. So the inherent material should be chemically resistant, high temperature stable material, and the large aspect ratio, the atomically sharp tip, and all these things put together, carbon nanotube is the ideal material which acts as a field emitter. Now, if you just imagine, once upon a time, the television used to be a back side, it used to be a cathode ray tube. Now there is nothing. Now it is a flat TVs are there because each particles will emit at low voltage. Otherwise, to bring that cathode to emit the current, you require a ultra high vacuum. You don't require now vacuum. This these particular carbons are carbon nanotubes were developed for defense applications, and we have observed that the highest field emission is possible from the edges only. So when you develop a full into a plate, we found that if we can incorporate that more edges, then the field emission can be increased. So we have used our laser scribing, like laser micro machining, to scribe that type of squares, so to get the more number of edges. And it was found that the emission is very, very high at low voltage. You can see the field enhancement factor has been enhanced from 3780 to 4500 cent per centimeter. So all these things are very high. Now we are working on a carbon fiber based field emitter for a very, very high emissive activities. Now, if you just take the carbon nanotubes paint and put it into a plastic also and pass a current, you will get the flexible television. I think somebody has to mute themselves. Yeah. Now, the carbon.
Sir, please unmute.
Sir, I think someone from the hosting team has kept all the persons mute. So take care of it, please.
But presentation is also lost, no?
Yes, sir. Maybe due to some disturbance, some of the host has been done something. I think so.
Yeah, I asked him to join again.
Okay,
Okay.
okay.
Yeah,
Okay, sir.
he will join us.
Sir, should we switch off and again rejoin, sir?
No, you need not do that, sir. Sir will join now.
Okay, sir.
Yeah, sir has joined back. Yes. Sir, please share your screen.
Hello.
Yes, sir. Yes, sir. You are audible. Please share your screen.
Yeah. Okay.
Yes.
So you have to guide me up to what slide it was.
Yes, sir. Yes, sir. Sure.
So I'll go one by one. Then you just tell me where I have to stop. Because I think we were talking about the field emission somewhere.
Yes, sir.
Is
Yes,
it right? Yeah?
exactly.
Field emission of carbon tubes.
Yeah. I think because I don't know up to what level we were in the common platform. No
Yeah.
problem. I'll see somewhere we will.
I also request participants to mute because of such things. Actually, there would be this kind of technical hitches.
Yeah, sometimes unknowingly it happens. Hmm. Yeah, right. But it will, if they will mute it, sometimes video also off, so that it can be bandwidth issues can be resolved.
Yes, sir. Yes.
Yeah. So up to this we were there, right?
Yes,
No.
sir.
Okay. So now these graphite flakes are made, converted into a flexible graphite. And now this flexible graphite can be developed this type of product. Now you see the product gasket. Looks to be simple engine gasket, but very, very highly engineering component because you require the compressibility. It has to withstand the temperature. Can we touch the silencer also even after running a 1 hour of automobile? No, because heat is too high. Now in engine, that type of heat is there. This is the VAP seal, means wheel and axle plant. When they are casting their wheel, it is being used. Now bipolar plates you can see in one of the corner, the boards. Now if you see here, the test engines are there, which we test our gasket. I'm now at a little fast because now this is a cast area where the wheel is casted, and each point, this point, if you see the joint where earlier they were using the asbestos based gasket, now they are using the carbon based gasket. If you see, all the chips packet will be lined with the aluminum foil. Why this? Because most of the plastics are not food grade plastics, so you require to protect the food. That's why aluminum is given. Now this aluminum is made from the evaporation boat. This evaporation boat will pass a very high current, and it becomes like a 1300 degrees centigrade. Aluminum wire is just bring into the contact, and it will evaporate, and it will deposit onto the substrate, and that's how 3 to 4 micron of aluminum is deposited. This is a bipolar plate for the fuel cell applications. And one side bipolar. Why this is called bipolar? Because the same plate will be used as an anode for one cell and cathode for other cell. And it has a lot of challenges, like it should be impervious. Hydrogen and oxygen should not meet, and it should be highly conducting, and it should be chemically inert, no chemical this thing. And now this is the assembly or a stack of a fuel cell. Another applications of this graphite is into the oil absorption, like in oil spill. You will find that a lot of oil spill happen knowingly, unknowingly. All those things are there. Now this it has its own challenges because a lot of sea mammals, sea lives will get disturbed, and the whole tourism of the beaches will also disturb if there is an oil spill, and sometimes money loss, tourism loss, everything loss, life loss. Now, if you take this type of a highly porous structure, now this porous structure will absorb the oil selectively, make it a point. It will absorb only oil from the oil-water mixture. Now, if you see, this is a graphite powder which was put into like a simulated condition, and around 78 ml per gram will be absorbed by this. And now you can recover back the oil, and same thing can be recovered. Otherwise, the earlier people used the cotton fiber, the milk bead fibers, even the sawdust. I remember when we were child, sawdust were used for this thing.
నీ నెంబర్ నుంచి ఫోన్ రావడం ఎన్నిసార్లు చేస్తావు అని చెప్పి గట్టితో స్పీకర్ లో పెట్టండి.
అది కాదు, ఏ టైంలో చేసి నాకు చెప్పదు.
8:10కి. ఇప్పుడు
Srihari sir, please unmute yourself.
I have muted him, no problem.
Okay, can I continue?
Yes, sir, shoot, sir.
Okay, sorry. These are the setup which is for the real applications. Now, talk about the graphene. I'm also into about this thing, few slides or more. So, this remarkable properties of graphene will decide because it is a very, very extraordinary material which is having a high electron mobility, the exceptional thermal conductivity, superior mechanical properties, but in the lab level. How to bring these properties into the real application is a big challenge where the whole world is struggling. Now, we have used a different technique because our strength is to make the exfoliated graphite. We have taken this graphite, expanded graphite, and tried to sonicate it and then convert into a graphene, and that these things we got it, make it into a bucky paper. Now this is a few layer graphene, and you must be seeing, if you see here, if you do the proper segregation, you can get it from more than 20 layers, more than 15 layers, more than 7 layers. Even some of the parts are more than 3 layers, around 3 layers. So this, when you are working on graphene and other things, you require a little high-end Raman, because normal technique will not give you a idea about graphene, because the disadvantage of carbon research is everything looks black, whether it is a carbon black or the graphene or CNTs. You cannot see just by visual inspection. You require a high-end equipment. You can play with the chemistry of this graphene by you can change from hydrophobic to hydrophilic. All those things are possible by changing by the different treatment, and the angle of contact has varied from 67 to 109. This technology was transferred to industry, and in a long time it was with the incubator. Oh, this is already covered. So thank you very much. And if any questions are there, will be open for any questions.
Sir, I have one question.
Yeah.
Sir, actually, I am working on welding process. So
Weld-
where we
weld-
are getting welding process,
Yeah. Okay.
like non-consumable electrodes, I am using TIG welding.
Okay.
So where at the tip of the electrode we are having 20,000 degrees centigrade, but while coming to the bottom of the plate we are getting around 2,000 degrees centigrade. Sir,
Yeah.
is there any possibility that we can continuously disperse the nanoparticles so that we can constrict the arc, so that we can increase the energy density of the arc during welding? So it will increase the efficiency of the welding. At the same time, we can get benefited.
Theoretically, yes. Practically difficult. Because what is happening whenever any welding is happening, there is a lot of other like flames flow goes out to. So how to stick into the electrode will be a little challenge. But people have improved a lot by putting the nanoparticles into electrode, and improvement is there. But what you are talking about, that it will be like it will be continuous operation, it is going to be a little challenge.
Okay.
But possibility is there. If those who are working on electrode development must be using such type of ideas, how to disperse, how to make it into an electrode. So
Okay.
possibility is there, but only thing is those who are working, there is a lot of mechanical forces and that thermodynamic these things are there. It will be like the temperature is very, very high, and because of that it will flow off. But possibility is there.
Yeah. Because I constricted the arc with some external magnetic fields. As you said, in the industrial sector, it will be difficult to accommodate all the magnets in those field. So is there any? That's why my question is: is there any possibility to disperse continuously the nanoparticles? That's
maybe those who are working on those areas. One of our scientists is also, but he is a user of electrode, not into development of electrode. But if just put me a mail, if anybody is in this line, I will connect you.
Sure, sir. Yeah. Thank you, sir. Thank you.
Okay.
Yes,
Now,
Dr.
Sir.
Satyanarayan Reddy.
Sir.
ladies and gentlemen.
Okay. One question, sir. You mentioned about the catalytic converter.
Mhm.
So let me try to understand. Is it ARCI has made the catalytic converter, or the ceramic honeycomb thing was made?
ARCI role was only to make the ceramic honeycomb.
Okay.
Because that honeycomb structure helps but it is the platinum, the coating is done by some industry, and then it was a possible application of catalytic converter. But the same honeycomb we have used for multiple applications, like in an air heater or into the anti-mine boots inserts. So the same honeycomb was used with different composition of alumina.
Okay. Just one general question. Nothing to do with ARCI. Is this catalytic converter, is it being used in Indian cars?
Unfortunately, no.
Okay.
Mhm.
Okay. Then let me ask one more question. You mentioned about the quantum dots.
Mhm.
Any work is going on, sir, at the RCA? Quantum dots.
Quantum dot, one of our scientists is working.
Uh-huh.
Yeah, in quantum dots, he's working.
Related to the solar cells? Or?
Yeah, related to solar cell. Okay.
Okay.
Because many activities I have not put forward, but yes, he's working. If you give him the details of yourself, I will connect to that scientist.
Okay. One last question, sir. You got fantastic facilities.
Mhm.
Is it possible that we can get some of the things done on payment basis? I mean,
Why
payment
not?
basis actually we can't afford, like government establishments approaching you. Any concessional rates for the purely for the student research in colleges?
No, there are no. One thing is we are not there to make too much money from the characterization, but only thing the operational cost of the equipment we try to recover. Okay, but from the industry we charge little extra because those who are operating and other things, the cost will come out. But for students, we are taking very nominal charges. Okay. So whatever equipment you are having interest, just write to me. I will get connected to the individual scientist.
Okay. Okay, sir. Thank you very much. We really enjoyed your lecture. Thank you.
Yeah, one more question. One more raised hand. Narayan Rao garu.
Yeah.
Sir, very good evening. Dr. P.K. Jain, sir.
Hi, good evening.
Sir, I firstly, what a wonderful lecture on that carbon-based materials and carbon nanotubes and everything, sir.
Thank you.
Actually, my area of research is surface coatings. That is a PVD coatings, physical vapor deposition,
Okay.
and laser surface texturing for the aerospace materials, particularly dowel joint.
Where you are working? You are from?
Sir, actually, I am working from NIT Srinagar and IIT Delhi, Professor Deepak Kumar.
Okay, you are a PhD scholar?
No. Actually, I finished my PhD, sir, recently.
And okay. Now, okay.
Yeah.
Tell me. Yeah.
I have one question, particularly tribology area, the related question.
Mhm.
Sir, actually, how do you graphene and CNT nanotubes based coatings improve fretting wear resistance in aerospace components?
See, basically, all carbons are layered structures.
Yes.
So, whenever you are using layered structure by default, the improvement in the frictional properties will happen. Okay, graphite is very good for the frictional properties. That is undoubted. But the only challenge comes how to make this graphite adhere to your substrate.
Yes, that is the thing, sir.
Yeah.
Sir, sir, actually, I am doing some research on that TA grade 5. That is a TA64Li. For the laser surface texturing and that is the surface coating, I am using both to surface modification techniques for the enhance the fretting wear behavior.
Yeah.
But unfortunately, I have some thoughts to my elaborate my research towards the graphene materials. So, sir, if you have any inputs, please give me some context.
No. See, one thing is like graphene based or graphite based or anything. Why graphene is different from the normal graphite? Because it is having a single layer, 2 layer, 3 layer, 4 layer. Graphite
Yes, sir.
is like a few thousand layers. That's why the weight density is very, very high into the normal graphite. It will settle down. Now, graphene, because of its structure, they are very good. But how to make it into disperse into and to substrate is a big challenge. What you are doing it is one of our another group by laser texturing. They are doing it for the frictional improvement. They are also doing our laser center is doing similar work. If you want to interact, please, if you are having time, visit ARCI. I'll give the connections. Or else, if you want to know through a distance interaction, I will just connect to that particular scientist. You can interact with him.
Sure. Thank you, Jain sir. Sir, one more question.
No problem.
Sir, what are the recent advancements using the carbon-based materials for space propulsion? Is there any recent from your ARCA laboratory, sir?
See, what happens nowadays, all strategic sectors like space or DRDO, they themselves also do a lot of research, which never comes out in the open domain. Okay.
Yes.
So what is happening? Certain this is already it is being used the CNT or carbon nanomaterials into the propulsion, and high energy labs are there. Those who are working on that.
Yes.
And they take help of ARCI on a strategic applications.
Yes, sir. Yes. Sir, thank you so much for your wonderful answers.
It's my pleasure.
Okay, thank you, sir.
Yeah. Just if it is there, I'll have, if all participants are there, just for their fun and other things, few slides I have generally, I have made it. If it is all are okay, can I show?
Yes, sir, please.
Okay. This is a, what we call it, why people have fear to start new activities. Why people have fear to start new activity? Because they are in comfort zone. They don't want to go because it requires a lot of learning process. Then only they can go. So people are having a lot of fear to leave the comfort zone. But my feeling is life begins at the end of your comfort zone. And the distance between your dream and reality is called action. So all people, those who are having dreams, if they want really dreams to come true, they have to act. Then only they can achieve. Because what is happening, many times people runs, but they are running on the other side. You have to see what others are doing. See, and you have to come out from your mindset that Indians cannot do. So like this horse is tied up with a chair, feels they cannot run or he cannot run because this is a mindset. And Indians are having that they cannot do, only the white people only can do, or the Western world is having a high-end facilities. So, okay. Now, if you see many people, no, I'm not designed for small activities. I'm only designed for the bigger activities. So they don't take they wait till the bigger things happens. And those who does small things can go into the ladder very far. And many times all solutions are with us, but still we were trying to see outside to see like one person has asked this person. Now this person is a very big area where how to play with the chemistry. But if you are good in the chemistry, you can do your own dispersion. You need not to see the Google or these things. So most of the solutions are within ourselves. And similarly, but people always follow others. So it is like a train, if you see, people are loading. But if you see, many times your approach may be different, but it gives you a more result. So if you are not upgrading yourself, like a Fiat car, if you see, it is being used to keep the cow dung. So once upon a time, a premier car is not giving the satisfaction to the customer. It is being used like this. So one has to keep upgrade themselves. Then only the society will give you respect. Otherwise, you will be out of the game. And this man is having a lot of tire. But the tire, what is required, he's not having. So you have multiple ideas. But if those ideas are not doable, that ideas is no meaning in that. Are you getting a point? See, having ideas is no meaning unless that idea is giving you a solution. Okay? Thank you very much once again.
Sir, maybe after this last few slides, one of our senior most participant and an active participant, K.S. Gupta sir, has raised his hand.
Please.
Yeah.
Gupta ji, boliye.
Gupta sir?
Good evening, Dr. Jain.
Good evening, sir.
Fantastic presentation, and at the end, the boost to the what we call it motivation and jumping on the wall. But at the same time, you restrict to looking at others. That can you come back that previous slide? previous one. This one, I also teach by using all this. And here, if you look at, the person is looking at the wall to see others. At the same time, we say in the leadership context that misusing the resources.
Yes. Correct.
Instead of putting the straight ladder, so many ladders is putting.
Yes,
And that is what the productivity miss.
Yeah.
Anyway, thank you very much for.
Well, thanks a lot for giving me one more aspect of the same slide.
That's correct. Plenty are there. And the last one you said, keep updating, come out of the what is called comfort zone and all. I always keep myself updating, and I'm current and futuristic, whatever way possible.
That is
Thank you for enlightening me. About sometime I go as a interviewer for promotion in DRDO.
Oh, please
So
do
your
come to
side has
Hyderabad.
given me a lot of question. Technically, I can ask. Earlier, I was asking behaviorally.
You can whenever you are visiting next time to Hyderabad, please do visit to our lab.
Definitely, I will. I will contact you. You have given the.
This is my contact details, the emails, and my phone number.
1 second. Let me take a photo and then.
Yeah.
I will keep it with me, and then
you will take a photo. My photo also will come.
Yeah, that's how. Thank you. Thank you.
Thank you.
But excellent way of presenting, at the same time making a lay person. Of course, I'm not totally lay, but even lay person to understand because of your applications in day-to-day life.
Thank you very much.
Thanks a lot. And
Thank
I
you.
would love to learn something more.
Now, in fact, Gupta ji, here also the two important points. Whatever we know, this is like the tip of iceberg. Lot of things are unknown.
That's correct.
And if you follow your own instinct, even the Brahmand can come in your palm. That's what. So the whole solution lies in this.
And that is why you are updated, you are current and futuristic, everything. And I'm sure you will continue to help all others to develop.
Thank you, sir. Thank you.
And anytime you can have my talk, I do the mind reprogramming.
I suggest this thing, Sherry, if you can share the.
I will share with you.
No. What I suggest, even those who have attended if you can share the list of participants, and if anything, we are organizing. See, we are in the field of carbon. So next year we are organizing a very big conference, international conference in carbon in Hyderabad. So we want all participants to have a look on that. If they can attend, that will be good.
That's nice. And Dr. C. Eddie will help you.
Sure, sir. I will share across all the
my detail to you to utilize my services.
Yeah, sure, sir. Sure.
Confirm the people.
Sure. Yeah, sure, sir.
Thank you. Thank you.
Thank you very much.
Wonderful opportunity I have been provided now.
Yeah.
Yeah. One more raised hand. We are one. Sir, can you?
Sir.
Yeah.
Good evening, sir.
Yeah, tell me.
Sir, first of all, it's a very wonderful and interesting session. I'm very much fascinated by your examples taken from nature, which are motivating the research topics. Sir, my question may seem foolish or may funny, but out of curiosity, I'm asking this question for waste material. Do we have any CNT based PCM?
Oh, very good question. We work on PCM, sir, phase changing materials. I have not told because this is a very upcoming field. PCM, phase changing material, we work very vigorously and dispersing graphite nanoplates and CNTs we disperse into PCM and then use it as a thermal management applications.
Yes, thermal degradation.
No, thermal management like in a batteries where the thermal runaway. One of our scientists is working vigorously on this.
Oh. Especially for solar panels, if we want to apply that PCM.
Yeah. In fact, we are having a lot of different grades of PCM, like up to 50 degrees centigrade. One is PCM we have developed up to 250, and then using for generator heats and other things. our group is working.
Sir, is there any research going on eutectoid?
We work a similar line.
Okay.
Okay.
Thank you, sir.
On the latent heat and other things, we have equipment, STA to measure those things. We work on that. Of course, certain things which we have not published, we have not. I have not shown.
Sir, thank you, sir. Thank you very much.
Welcome. Yes, Dr. Srihariji, is that okay?
Yeah. Any other questions by participants? Yes, please.
No, sir. No, sir. I accidented by mistake. I get it.
Okay, so we can call it a day. CJ Rao sir, can you please summarize, sir?
Yes, sir. Yes, sir. I'm summarizing. A very wonderful session. Dr. P.K. Jain in his session shared insights on advanced materials research and characterization. He started with the International Advanced Research Center for Powder Metallurgy and New Materials, ARCI, an autonomous R&D institute under the Department of Science and Technology, Government of India. His presentation focused on ARCI's mission to develop high-performance materials, demonstrate emerging technologies, and facilitate technology transfer to Indian industries. Additionally, he highlighted the Center for Materials Characterization and Testing, emphasizing its expertise in structural, microstructural, mechanical, and electrochemical characterization of materials. He discussed the center's state-of-the-art facilities, research objectives, and core strengths, particularly in nanotribology, X-ray diffraction, electron microscopy, and electrochemical analysis for applications in energy storage, coatings, and industrial sectors. Through his session, Dr. P.K. Jain provided a comprehensive overview of ARCI's role in advancing material science and research, fostering industry collaborations, and contributing to India's technological growth. Dr. P.K. Jain emphasized the pivotal role of the Center for Materials Characterization and Testing in advancing material research and industrial applications. CMCT specializes in structural, microstructural, mechanical, and electrochemical characterization, providing state-of-the-art testing facilities for industries and research institutions. It plays a crucial role in developing and analyzing materials for applications in batteries, coatings, solar cells, and corrosion resistance. A key highlight of the session was CMCT's active involvement in technology transfer, ensuring that research innovations reach industrial applications. Ongoing projects include antibacterial nano-silver coatings for medical use, self-cleaning nano-titanium dioxide coatings, and nano-silver treated textiles for antibacterial applications. Dr. Jain also highlighted the successful commercialization of exfoliated graphite products, that is reinforced graphite sheets and seals, and evaporation boards for metallurgical industries, showcasing CMCT's impact on real-world industrial advancements. On behalf of everyone present, I would like to sincerely thank Dr. Pawan Kumar Jain for his insightful and engaging presentation. His expertise in materials characterization and carbon-based materials provided us with a deeper understanding of their applications and industrial relevance. The session was highly informative, and we truly appreciate the effort and knowledge he shared with us today. Thank you for your valuable time and for enlightening us with such a thoughtful, provoking discussion, sir. Thank you, sir.
Thank you very much.
Yeah, we all thank you, sir.
Okay. Can I
Sir,
close?
sir, thank you, sir. Sir, next PK, sir.
Thank you very
Hello,
much.
sir.
Yeah,
Hello, sir.
Yeah.
Sir, I will be in touch with you. If you don't mind, can I call you, sir, after some time for my research work?
No, absolutely no problem. Only thing is, because what I suggest, anybody who wants, just send a message in a WhatsApp. Okay, because the same number is WhatsApp. And as per, because what happened many times, I will be in the meeting or something. Immediately, I cannot lift the phone.
Yes,
but
sir.
I will definitely respond it as per this thing, and I will try to help you whatever way it is possible.
Okay, sir. Thank you, sir. Thank you.
Thank you.
Thank you very much.
Thank you. Can I close, Sri sir?
Yes, sir. Thanks.
Yeah,
Thanks a lot.
Yeah,
Good
thanks
night.
a lot.
Good night, sir. Yeah.
Good night.
Participants, feedback link is already there. Those who want to give feedback, they can give the feedback and leave. And we'll meet tomorrow, 6 p.m. Thank you. Good night.